Okay, so a couple things I left on your desk. First thing was the notes. The stapled, that's the notes we're going to cover the first part of chapter 4. The next one is vocab. We're going to get a lot of vocab for this chapter. The reason being is because there's virtually no math in this chapter. There is very little to any math. Exactly. That's a lot of people's favorite. The calculator we'll use, but not for calculations. We'll use it for other things, which I'll tell you about when we get going. Okay, so this chapter, like I said, for a lot of people, it's their favorite chapter because like I said, we virtually do no math in here. We do a little bit of math, but it's not, there's no real calculations. There's nothing to calculate. There's nothing to plug in. There's nothing like the chapters we've done. And some people don't like it because just the way your brain works, right? However your brain works. Some people, it's more of a science. Chapter 4 is more like a science class. And a lot of the terms you see on your sheet, on your vocab sheet, a lot of them should sound familiar, especially if you've taken psychology or AP Bio or Bio. A lot of those words sound very similar, very familiar, okay? Because we overlap. This class overlaps with AP Psych and AP Bio. Some of the chapters kind of intertwine, okay? Because like I told you guys at the beginning, statistics is a math, but it's also very much a science, okay? So it mixes with those two sciences. All right, so that being said, let's see. So the first part of chapter 4, we talk about samples, okay? What a sample is, how to get a good sample, what's the difference between a good sample and a bad sample, all that stuff, okay? So first word, population. Population is in a statistical study is the entire group of individuals we want information about. So a population could be very small or it could be very big, okay? A lot of people think population means huge. No. The population of this class is right now 14. Or it could be the population of the United States, 350 plus million, right? So it just depends on who's the whole group, okay? A sample is a part of that group. A sample is a part of the population from which we actually collect information. Again, it could be small sample or it could be a big sample, okay? But if it comes from that population, then it's a sample of that. We use information from a sample to draw conclusions about the entire population, okay? So samples is what we work on, what we deal with, but let's say, what is it called if I get information from the whole population? Don't take a sample, get information from the entire population. Does anyone know what that's called? That's a census, yeah. A census is from the entire population. So whatever you need to do, whatever information you need to extract, you extract it from everybody in that population, okay? Every 20 years, not 20 years, 10 years, every 10 years, the United States conducts what's called a census. Census is you get mailed, it's about like that big, a folder, and it has all types of stuff mainly about the people who live in this house, okay? So however many people live in your residence, house, apartment, wherever you live, your residence, it asks questions about them. How many people are they? Ask questions about the economics, like how much money do you make? Ask questions about ethnicity, ask questions about all types of stuff. And because it's done, it's actually part of the Constitution that they have to do it every 10 years to figure out what does the country look like. Country looks very different from when we did it 20, 30 years ago, okay? Problem is, what's the problem with doing a census? A couple problems. What's one problem with doing a census of the United States? It's hard to get everybody, right? Census means you have to get an answer from everybody, right? Well, not necessarily everybody, it's every household, right? Every household. Like my kids didn't answer the census because they're kids, but I answered for them, right? Because they live in my household. So how do you get in touch with people who don't return it back? So if you get the packet back and you don't send it back, doesn't mean it's over. They still got to get information from you. Right? So there's ways they go about this. You know, they call, they knock on your door, they figure out ways to get in touch with you. They do this every 10 years. So it's extremely hard to get information from everybody or every household. And if they don't, it's not a census, because a census is everybody in the population. What was another? So that's a good one. It's hard to get in touch with everyone. What's another one? What's another reason why census is tough? Take a long time. Take a long time because you have to get in touch with everyone. You have to process all that data. So it takes a while, definitely. What's another reason? Well, census is truthfulness. Yeah, truthfulness. People can straight up lie. That could happen, right? What's another reason why? There you go. Yeah, we have not everyone lives in a home. Not everyone lives in a stable home, right? There are people who move from place to place because that's how they live. That's how they have to live, you know. There are people who are homeless. So it's hard to get in touch with everyone, okay? So that one's kind of like what Josh was saying earlier about it's hard. What else? What else reason why? What else is a reason why? People might not just want to do it. Yeah, it's hard. It's hard to get everyone. It's hard to get everyone on board, right? Census doesn't take very long. Like I think when I did it with my wife, when I answered the questions, it took us less than 10 minutes to answer everything. But a lot of people don't want to do that. Okay. What's another way? Another reason? There's another big one. Costs a lot. It costs a lot of money. And guess who pays for that? Taxpayers pay for that. It comes from the federal government. The federal government pays for all of that. And they don't just have money from anywhere. They get it from people who pay taxes. Okay. So it's taxpayer money. So it's very cost heavy. And a lot of people have said it's not the most efficient way. You guys have brought up some good reasons why it's not that efficient. So there's a big push in Congress to say, hey, let's not do the census anymore. Let's just take a really good sample. Because if we take a really good sample, it'll tell us the same type of data that we would get on a census. Okay. Now, if you think about it logically, how are you going to get the same data from asking a smaller group of people than you would if you got a bigger group of people? Makes sense, right? How are you going to get that good data from them if you don't ask everybody? You just ask a small. Who are these small people going to be? Like if you only ask, instead of 350 million, let's say you only ask 1 million. Who are these million people going to be, right? Well, that's the part of what we're doing in this chapter. Okay, at the end of the chapter, hopefully you'll think samples are extremely efficient. It's a lot more efficient way of doing it because it's less people, less time, and it gives you the same data. Okay. Yep. So that's census. Okay. So we don't look at census, but it is one of the things that it's kind of the opposite of a sample. Okay. All right. So the idea of a survey. So one of the things, if you get a sample, one of the things is ask them questions, right? It's kind of like the census is a survey, right? Except it's not a sample survey, it's a census survey. So the idea of a sample survey, okay, step one, define the population. So who are you trying to get information from? Is it period 7, room 87, us 14? Is it everybody? Is it all citizens of Fresno County? Is it all citizens of the state of California? Who is it? Is it all students enrolled in Central High School? First of all, you got to define who you want your data from. Who do I want my information from? That's the first thing. And then the second step, say exactly what we want to measure. A sample survey is a study that uses an organized plan to choose a sample that represents some specific population. So once you have your big group, right? Once you have your big group, Then you can come up with your sample, okay? Because you need your population first, okay? Decide how to choose a sample from this population. So obviously you want it to be random, right? Random. I don't want to be able to pick. If I'm taking a sample, I don't want to be able to pick who's going to be in my sample. That person, that person, that person, that person, that person. It's not a good sample, right? It's not going to tell you what you want it to tell you. Or it might be bias, what we call bias. So what is random? So if I say the word random, what does that mean? We use that word all the time. But if it's truly random, there's two things that need to happen. What are those? What's one thing about randomness? Human choice, not human choice. If I'm coming up with my sample, I can't have any say in it. Whether it's, because some people say, well, how about this? How about if I just do this? My eyes are closed and I pick a person. Well, you still have human choice because I know who sits over here and I know who sits over here, right? So it's not really random, right? I could walk outside and say, okay, the first 3 people I see. You're like, that's random. Not necessarily, because not the whole school. If my population is the entire school is not going to walk by my classroom during 7th period, right? Only the kids that have classes around here, right? So to be truly random, you have to have no human choice involved. So there has to be what set up? There has to be it's not in there, but starts with an S. You have to have a system. You have to have a system set up, a system. We're going to talk about systems down here. Okay. So no human choice, and you have to have some sort of system for choosing the people that you are choosing. So a system means I can explain it. Okay. A system is, for example, if you want to use a restroom, raise your hand, ask to use the restroom, and then I say yes. Most likely I'll say yes. You grab the pass and you go to the restroom. That's a system, right? That's a system for what we do, and I can explain it to you. You can explain someone something, that's a system, okay? So if I have a list of 10 people and I said, okay, these are the people I chose randomly, I have to be able to explain the system in which they were chosen. I had no choice, but I have to be able to explain how they were chosen, okay? That's a system. Okay, so how to sample well, okay? Statistician's remedy is to allow impersonal chance to choose the sample. That word right there, chance. Chance means there's no control, it just happens. Okay, a sample chosen by chance rules out both favoritism by the sampler and self-selection by the respondents. Okay, we want to rule out favoritism, certain people we want to choose, or certain people, like whether it's consciously or subconsciously, you want to rule out favoritism of a certain group of people or people in general, and people specifically, and self-selection by the respondents. I shouldn't have a choice and you shouldn't have a choice about who's in the sample, okay? Because if I have a choice, it's not random. If you have a choice, it's not random, right? You're volunteering, right? Random sampling, the use of chance to select the sample is a central principle of statistical sampling. Randomize, let the chance do the choosing. Randomization can protect you against factors that are in the data and factors you're not even aware of, subconscious things. You're not even aware of it happening. Randomizing makes sure that on the average, the sample looks like the population. There we go, right there. Looks like the population. That's what we want it to do. We want our sample to look like the population. And if you do correct randomization, it will look like the population if you do it the correct way. Okay. Okay, so types of samples. Here we go, types of samples. The first one is the biggie. The first one is the biggie. It's called a simple random sample, or SRS. This is the best. This is the best random sampling method there is, okay? So a simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected, okay? So a couple examples. Random number table we'll talk about later. Graphing calculator, I'll show you how to do that your calculator can actually do random samples, SRSs. Names out of a hat. Put everyone's name in a hat. Put everyone's name in a hat. Not looking, close my eyes. I don't know who's on this side, who's on the left side, who's on the right side of the hat, right? If I mix them up like this, I don't look, I pick out a name. That's my system, right? I could explain it to you. I had everyone put their name on a piece of paper, had them put it in the hat. I mixed it up, I closed my eyes and I picked one. That's my system. Did I have any choice of whose paper would get chosen? No, as long as every paper is the same, right? Paper is the same color. Everyone has the same size paper, so I can't tell that way. That's a system, okay? So that's the best system. The best way is a simple random sample. Sometimes though, it's not possible, okay? So another random sample or random sampling method is what's called the stratified random sample, okay? Stratified, strata, it comes from the word strata, means groups, okay? So it involves the following. Divide population into strata. Strata are homogeneous layers. What's homogeneous mean? Same, groups that are the same, right? 9th graders, 10th graders, 11th graders, 12th graders, they all share their grade level the same, right? So if I put all the 9th grade names in a hat, that's homogeneous because they're all 9th graders, right? Subpopulations. Okay, so, and then from there, we take an SRS from each strata. Example of this, same thing. I took, let's say I have 4 hats now. I have 4 hats. So I ask all the 9th graders on campus, put their name on a piece of paper, put it in the hat. Then I go and ask all the 10th graders on campus, put your names in a hat. The same thing. Different hat. Next hat, all the juniors, put your names in a hat. Last one, all the seniors, put your names in a hat. So I have 4 different hats, right? My strata is based off grade level. Then I went over here to the 9th grader, randomly picked out 10. Went over here to the 10th graders, randomly picked out 10. Went to the 11th grade hat, randomly picked out 10. Went to the 12th grade, randomly picked out 10. That's an example of a stratified. Now, why might stratified be more appropriate sometimes than simple random sample? Exactly. If I want to get surveys to all students at Central High School, this guarantees that I get the same number of surveys from each grade, right? Or if there's not as many freshmen, I can say only 5 freshmen I'm picking and the rest 10. Or if there's not as many seniors, I can say, okay, seniors, I'm only picking 5 of you guys and 10 of everyone else. So I can change it that way, okay? So sometimes it's the best, sometimes it's the most appropriate. It's never the best. The best is always SRS, but sometimes it's more appropriate for what I'm trying to do. So let me ask you this. Didn't I just use pretty much the same example for SRS and simple and stratified with the names in the hat? So why is the names in the hat for 9th, 10th, 11th, and 12th graders, Why is that one not a simple random sample? Didn't I use the same system? There are different groups, that's one of them. So creating different groups, homogeneous groups, based on something. Equal representation, that's what happens with Stratify. The reason that those are both correct, and the other reason is that if I did a simple random sample, so let's say I put everyone in Central High School into one big hat and chose 50, or sorry, 40. Was it my name in one of the 4 hats? If I'm a student here, wasn't my name in one of the 4 hats? And my name is in the big hat, right? So an SRS would be one big hat, pick 40 students. I still have a chance of being chosen, right? Because I'm in here, I'm 1 out of whatever, 1,100, 1,000, however many students we have on campus. Here, you're in a smaller group, right? So you still have a chance of being chosen. The difference being that the samples aren't the same, right? If I choose one from each hat, it's going to have to be 10 freshmen, 10 sophomores, 10 juniors, 10 seniors. It's not possible to get 20 sophomores, 5 freshmen, 10 sophomores, or 10 juniors, and 15 seniors, right? It's not possible. But in my big hat, it is. Isn't it possible in my big hat to get no seniors? Isn't it possible to get no freshmen? Not possible when I'm stratifying it. So there is some limitation when you're stratifying it. There is some limitation. With simple random sample, all systems go. I could get all juniors. I could get all freshmen. I could get half juniors and half freshmen with my 40 samples, right? Now the chances of that happening are very small, but it could happen, right? It could happen. So that's the difference. There's a slight limitation with stratified. SRS, there is no limitation because everyone's in the same app. Okay. Okay, so that's the difference there. Cluster sampling. Cluster. First, divide the populations into smaller groups. Ideally, this cluster should mirror the characteristics of the population. Then choose an SRS of the clusters. All individuals chosen in the clusters are included in the sample. Okay. I want to give a survey to parents of students at Central High School. A cluster sample would look like this. I would put all of the teachers who have a second period class, all the teachers who have second period class. I have a second period class. I'd put all of them into a name. Some of them have prep periods, so they don't have students. So if you have students in your classroom during second period, put your name in a hat. Pick out 5 teachers. My name got chosen. Everybody in my second period class would have to take the survey. Okay. So that's a cluster sample. A lot of these are very similar. So make sure, you're taking note of exactly how we're doing. A cluster sample one more time. So a cluster sample is one example. There's many examples, but I'm just choosing one example. Put every teacher's name who has a second period class into a second name into a hat. Pick out 5 teachers. Once I get those 5, everybody in that sample, all the teachers in the sample have all their students take the survey. How is that different from the 2 that we've seen before?
So it's like a stratified, but you don't choose one.
So it's similar to stratified, only one hat though. So there's groups involved, right? Teachers. But what happens when my name gets picked? So let's say there's 5 groups that get chosen, 5 teachers that get chosen. What happens if my name gets chosen? Who does?
Students in your second bullet.
All of them. What is that called?
The population.
Census. It's a census, right? So if everybody in the class, then that's a census. That's not a sample. Okay. So you start with a sample though. Where was the sampling done? Teacher names, right? Teacher names. So there is sampling done. It's random. But once your name gets chosen, then everyone in there. So there is a census involved there. That's where it says, that's where I bolded all individuals in the chosen clusters are included in the sample. So this is really the only one where we have whether we have a census in there. Okay. I had no choice over which teachers were getting chosen. There's my randomness. But once I figure that out, then everyone in that group that's chosen gets to take the sample. So it's clusters. Okay. Systematic. Systematic's probably the most simple. Randomly select the starting point. And then, for example, every 10th person or 20th person or 5th person gets your survey. Okay. So if you guys are randomly seated, you guys aren't randomly seated because most of you guys are in alphabetical order. But if I randomly sat you guys down and then I counted every 5th person, so you have numbers on your desk, right? Every 5th person takes a survey. That's systematic. That's systematic. Okay. I have no choice because you're randomly seated, right? I didn't choose your seats. I just had a random seating chart arrangement, and then I randomly selected, and so every 5th person or whatever. Okay. Systematic is usually the one you see most often. I'll give you a couple examples. Checkpoints. So if you're driving down the road, usually at night, checkpoints. There's checkpoints for different things. Most common one is probably driving under the influence checkpoint. They also have one for insurance though. Like they'll check to see if you have insurance. And there's different things they'll do checkpoints for. There was a crime or something, they want to stop everyone to make sure, stop people, not everyone, but they want to stop certain people to see if they saw anything or whatever. So checkpoints, how did they decide who goes through and who they stop? This is how they decide. It's predetermined. The police or the sheriff or whoever's doing the stopping, if it's a checkpoint in the city, the police, if it's in the district or it's in the county like us, it's the sheriff's department, they come up with an idea. We're going to stop every 5th car. We're going to stop every 6th car. We're going to stop every 20th car. So checkpoints, you'll see a lot of times they're like this, okay, come on through. And then they'll say stop. Like, why did I get chosen? Because it was a system. They had predetermined that system, they'd stop every car, and then they go ask that person questions. Have you been drinking, or do you have insurance, or whatever, blah, blah, blah. And then they go the next car, the next 5th car. They'll do it for that way. Okay. Surveys. So like sometimes if you're walking through Fashion Fair, or you're walking through River Park, or you're walking through like Disneyland, right? And then if you're walking through like Disneyland, usually at night, what happens is right before you get outside the park, there's usually people with iPads. And sometimes they'll stop you. And they'll ask you, how was your day-to-day at the park? And they'll ask you questions like, did you go here? Okay, okay. And they thank you, it's just a survey, right? So how do they decide? Most people walk right by. How do they decide who they're gonna stop and who they're not gonna stop? It's usually a system. Every 5th person that walks by me, every 10th person that walks by me, I'm gonna ask, right? Because sometimes you're walking by them and they don't bug you. I know at Edwards Sim, it's not called Edwards anymore, but when it was Edwards at River Park, same thing, walk by. And then they get surveyed. They'd ask you surveys. They would say, sometimes they would say, can I stop you and ask you some questions about the movie you saw? Or you ask you questions about, can you watch previews, you know, some trailers and tell me what you think? They've stopped my wife before. And they're like, why'd you stop you? Well, it was some sort of system set up so that the 5th person walking by, the 6th person, the 20th person, they stopped and they said, can I ask you some questions? And if they said no, then you'd go to the next 10th person or whatever. You know, sometimes they do that. That's a system setup. That's a system setup there. That's predetermined. It's not determined then, it's determined, okay, we're gonna ask the 5th person. We're gonna ask the 10th person, okay? The next one, multi-stage sampling, multi-stage sampling. Okay, multi-stage sampling. Multi-stage involves randomness at more than one stage. So it's kind of like a cluster, kind of like strata. Be careful not to confuse it with cluster though. Okay, so multi-stage is this. You start with a big group. Randomly pick some from there, so the group is smaller. Randomly pick some from there, group gets smaller. Randomly get some from there. So far, you just keep going down and down and down until you have a manageable group that you can handle. Okay, so this is, you see this one almost all the time. If you go stop by fast food, sometimes we have products at McDonald's, Taco Bell, whatever, that other parts of the country don't have. We have, you know, whatever tacos or whatever. Other parts of the country don't get that. How do they decide Fresno is the one I want to pick? It was done by a multi-stage sampling, okay? For example, I think this was like 5, 6, 7 years ago at Taco Bell, they had tacos that had, the shell was a Dorito. The shell was like a Dorito, nacho cheese Dorito. The shell was that, right? Not everywhere in the country got those. What they did was they said, okay, so they started with every state in the United States. They randomly picked 5. From those states, then they said, okay, we're gonna take those 5 states and break them up by counties. Put them in a hat, pick 5 counties. Okay, and from those counties, we're gonna pick the 3 biggest cities in those counties. Put them in a hat. Whichever ones we pick, those are the ones that are gonna get our new product. And if they like it, we'll expand it all over the country. That's how we got it. When I was a kid, McDonald's used to have, McDonald's sold pizza for a while. They sold pizza. It was personal pizzas, little rectangle pizzas. You could buy it. It was like a meal. You could buy it. And when I was a kid, I loved it. You know, when I was loved it. I liked it a lot. Lo and behold, they didn't do that everywhere. They didn't do that everywhere. They only did it in our town, in Fresno. They did it a couple other places, but we were one of the chosen markets to test that out. Okay. Obviously it didn't work out because they don't sell pizza, but it was one of the things that we were chosen. Okay. So one of the reasons why this is, a lot of companies choose this because they don't want to release it across the country. They want to keep it very small, right? Because it costs money to release all this stuff across the country and they don't even know how it's going to do. We think it's going to do well, but we want to get a little bit, we want to get a little sample. And if in that sample it's doing well, then we're good. Then we'll release it everywhere. If not, let's not waste our time. Let's not waste our money. Okay. So that's multi-stage. All right. So we're going to skip this stuff right now. We're going to skip the bad parts, the how to sample badly. We'll do that. But I want you guys to do some practice. Skip ahead to the examples, where it says examples method 1. So convenience sample, something that's convenient or a convenience. What does that mean? Easy, right? Easy, right? Convenient means it's easiest for me. Okay. I didn't mention that as one of the methods, sample methods on purpose, because it's a bad one. It's not a good one to do. It's whatever easiest for me. Okay. So here we go. A farmer begins by choosing 10 plots. So he's got 100 plots here. Every square represents a plot. So a farmer begins by choosing 10 plots that are most convenient for him to harvest without any other considerations. So which 10 would get marked? Mark those 10 that you think would get marked if he did a convenient sample. What does convenience mean? What does it mean again, Josh? Easy for the farmer. Which 10 would he choose if it's easiest for the farmer? Mark 10. Well, which 10 would he choose if it's easiest for him? The ones by his house, the ones where he has to take the least amount of steps, the least amount of time to get to. So am I going to choose this one way over here in the corner? No. Choose the ones that are closest to him. Well, these right here are right by his house, right? The plots, the row of plots or the column of plots that's exactly closest to him. That's a convenient sample. So that's the one he chooses. He or she, I should say. The farmer has second thoughts about the selection and has decided to come to you as an AP statistics student to help him, oh, it is a him, determine the approximate yield of the field. You are still using 10 plots to harvest early. Your job is to use one of the following methods and decide which method is best to use. Okay. Okay, so the next method is an SRS. The next method is an SRS. How would I do this one? No longer convenient. So what would I do for an SRS? I'm not asking you which ones I would pick. I'm saying what would be my system? What's one way to do a system? What's one system? I'll give you a hint. There's literally an infinite number of correct answers. That works. How many spots are there? 100, right? So if we assign each of them a number, each square is a different number, and then set up some sort of system so that I pick 10 of those, right? What sort of system would I use to pick 10? So that's another way of doing what? That's a simple random, but what is another way of doing that besides that? If I didn't have technology, what could I do? There you go. Isn't that the same thing as a hat? Right? It's the same thing. It's the same idea. It's the same idea. A lot of you that are more technology savvy, that immediately comes to you, which is good, but not everyone's that way. So I use the hat, right? Even though I would never use a hat because I'd have to cut up 100 pieces and put them in there and enable them. It'd take a while, right? But it's a good picture to have in your head of what that is, right? So what I would do instead is something like that, but technology-wise, right? Okay, so let me show you on your calculator how to do that. Okay, so there's a couple options that our calculator does. Our calculator will do random. It has a random number generator? Okay, let's see. Okay, so if you want the random number generator for our calculator, you go to math. You go to the math button right underneath alpha. Okay, yep, you're going to go over to probability. Okay, and then the last 4, 5, 6, 7, and 8 have the first 4 letters are rand. That rand means random. Okay, so the last 4, random interval, random norm means normal distribution. So if you want them to give me random numbers within a normal distribution, you use that. Random bin, we never use. Okay, so most of the time we use random interval or random interval no rep. What is the no rep? Take a wild guess. What do you think no rep means? No repetition. Yeah, what does that mean? I don't want the same number twice. Sometimes it's okay, sometimes it's not. Like you're like, I don't want to get the same number twice. Sometimes it's okay. So for this one, which one, is it okay to get the same number twice for this one? We don't want to get the same plot twice, right? So we would go to random, no repetition, random interval, no repetition. Some of the calculators don't have this and some of the calculators do have this. So watch. This is some of the newer, does anyone calculator when they press it not have this? Okay, so you guys have from our class set, they're the older, so they have the older operating system. But just listen, it's the same numbers. You're gonna put in the same numbers. The first number you're gonna put in is the lower. So what's the lowest number that I would have for the first plot, right? What's the highest number I would have? 100. What do you think n is? The number I want to choose, 10, right? Okay, so when I hit enter, this is what you guys are going to put in. You guys can put that in. 1, 100, 10. First number is where do I want to start. 100 is I don't want to go over this number. How many do you want to choose? Okay, and then when I hit enter, it's going to give me 10 random numbers between 1 and 100, never repeating. Exactly. None of us got the same numbers because it was random. Okay, how many people got an error there? Again, those are those calculators over there. The old system, the old OS had some bugs in it. The new OS, they fixed it. But the old OS, if you're getting an error there, you don't have this. You don't have this capability, okay? The new OSs do because they fixed it. They fixed the bug, okay? So I'll show you how to do it in a second. So look at first, all of these numbers are 1 to 100, and they are all random, okay? The calculator's got a random number generator. Okay, so let's say you have the system, the old OS. So what you're gonna do is you're gonna go to the same thing. You have no choice. You're gonna put random int, which means there could be, oops, nope, let me delete that. Okay. So if you have one of our calculators with the old operating system, you have no choice. You can't go no repetition because it's the system's got a bug in it. So you're gonna have to go here. Now, the only bad thing about going here is that you could get some numbers that repeat. So what if I say, okay, go from 1 to 100, pick 10, and then what about if one of them repeats? What do I do for the 10th number? How do I get that 10th number? So let's say I do this with no repetition, right? Or sorry, with repetition. This one's with repetition. And I get 10. And I choose 9 of them. So it gives me 9 unique numbers, and then the 10th one is a repetition. So that means I only got 9 numbers. What do I do to get the 10th? Just what? You could do it again. What if I get another repetition? What if I get 2 repetitions that time?
Keep doing it till it works.
You could do that. Might take a while. Or what's another way I could do it?
Find new calculator. I don't know.
There you go. Right? Instead of saying pick 10, let's pick 15. Let's pick 15. Right? Let's say 15. So this is what you guys would put in. 1, 100, 15. I don't want 15 numbers, right? I just want 10. Okay. So when I hit that, the first 10 numbers that are unique, those are the ones I want. Okay, those are the ones I want. Scroll down. See this little arrow down here?
Yeah.
And you got to go up to here. You got to go up to the actual number. So go up and then here. And then you scroll down. Wait, it's not working. Why is it not working? That's weird. It's never happened before. I put 15.
Oh.
So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's only 9. Okay, so I have there's another way of doing it. I don't know why it's doing that, but to make sure that you get all your numbers, do it this way. Do it this way. Go to math. Same thing, right? I have the bug in my system, so I can't go no repetition. So I'm going to do this. I'm going to say pick 15. I'm going to pick the first 10. If there's a repeat, I'll just go to the next one. Okay, so I go here. Don't hit enter yet, because enter is going to give me the same problem it gave me before. What you're going to do is you're going to go to this stow with an arrow. Stow with an arrow. You see this guy right here? Stow with an arrow right above the on button. That means store. Store it somewhere. Well, where do we want to store it? L1, L2, L3, wherever you want to store it. Tell the calculator I want to store it in L1. Enter. There's my list again, but again, do I have the same issue? Oh, no, that time it's working. Okay. Well, let's say it's still an issue. Then you just go to L1 and it's there. Those are the numbers there that my calculator chose. 73, 2, 43, 31, 98, 3. Okay. So if you're able to see them, great. If you're not able to see them, that's the way you go. So you put them in a table. So now they're in a table. So now I can see them all. So the first 10 is the ones I want to choose. There are 15 of them. Okay. Mhm.
You put math here, and just enter. Just don't go up or down, and then you'll be able to move.
Okay. There you go. I knew there was a way. Yeah, you don't highlight it, right? Just go side. Yeah. But if you want to see them in the list, there you go. That's the way. Store, and then it says where do you want to store them? In L1. Okay. Okay, so here's my list. I came up with a list. I got my list. Oops, let me go down. My first number is 73. Which square is 73? That one? That one? It could be, right? So I got my list. So how do I know what 73 is? What do I have to do? You have to number them. You have to number them. So you have to decide which one's number 1 and which one's number 2 and which one's number 100. Now, I don't want you to actually put a number in every box. Don't do that. Come up with a system, right? So here, this is what I would do. To number the boxes, what I would do is I would say, okay, so we go from 1 to 10. So for example, if I get this box here, I know this is 1, 2, 3, 4, 5, this is 6, right? And then from here, this is 11 to 20. Or you don't even have to put 20 if you don't want. This is 21. This is 31. This is 41, 51, 61, 71, 81, 91, and then the last one would be 100. So they all have numbers. I just didn't actually number them. So if you told me number 73, I'd go, okay, here's 71, 72, 73. Put an X in there. Okay. That's important. That's just as important as coming up with random numbers. I think Josh said it earlier. We got to give each one a number. You do. But if there's 100 of them, I don't want you to sit there and say, this is number 1, this is number 2, this is number 3, this is number, that's a waste of time. Okay. All right. Okay, so we have about 3 minutes left. So tomorrow what we're going to do is you're going to come up with your sample. Or if you're doing your sample right now, X. If you're not, if you haven't done it yet, finish up the 10 that you're going to pick. If you haven't done it yet, we'll do it tomorrow first thing. If you started marking them, make sure you finish. If you haven't, because you have to start over. If it's your calculator, yes, that works. But if it's not your calculator, what are the chances you're going to pick up that calculator, right?
Yeah, check the previous.
Exactly.
Man,
Okay. So if you didn't pick your 10, you're going to start fresh tomorrow when we get in here. Okay. If you did pick your 10 already, you're good. Your 10 are chosen. All righty. No, I'm not going to post. There's no new assignments because we didn't finish. Okay. So we'll pick up where we left off tomorrow.